Hello everyone, and today we are going to discuss the second machine learning algorithm, which is related to the classification, and it is none other than the logistic regression, which we normally use to classify things, especially if we have two classes and we want to identify the object in one of these class. We normally use the logistic regression, and there's a history why linear regression doesn't work. We're gonna see now, but that's where the logistic regression comes into the picture. That if we have two categories where we need to classify as yes or no, the logistic regression comes into the picture, and then it classifies. So let me quickly show you first that why linear regression is not a suitable option to use for the classification, because last time we discussed the linear regression algorithm and we have seen that it predicts the value. So obviously the question comes into the mind, the linear regression is very simple, it's easy to understand, it easy to use. Then why we don't use the linear regression for our logistic regression for our classification problem? So to answer this question, let me first show you a quick background and also the example scenario. All right. So, for example, let me just put something. See, I think full screen would be better. Yeah, now we can see much better. Yeah, and I can go. Yeah. So if you remember in the last video, once we discussed the linear regression, we normally see that there is a straight line that cover most of the data points, and based on that line, we draw the line equation for the linear regression, and obviously then we predict the value by using that line equation. And obviously within that line equation, we have couple of unknowns that we need to calculate, and in the math we have seen that how we can calculate those unknown. But now coming back towards the classification problem, where obviously we have multiple classes and we need to classify an object between one of those classes. So how are we going to do it? Obviously, especially with the logistic regression, if you can see, we only have, for example, we have two classes where the object can either be part of class 0 or class 1. And let me take an example. So for example, if we want to just if you want to consider a very famous data set which is related to Titanic, where we have bunch of people who were on the board, and then we want to predict who is going to survive and who is not going to survive. So obviously there are some people who are old or who are very young. The chances of them surviving the crash is going to be very low. But obviously people who are in their teenage or in their adult life, they have more power and energy, their chances of survival are more. Now have a look, we are seeing chances of survive, but at the end the result is either going to be one. Either they are going to survive, which is obviously one, or they are not going to be survived, which is zero, right? So there can't be in between. So you can see with these kind of problem, where we need to classify object into one of the scenario, is it going to be 1 or 0? Obviously if we use the linear regression, the line which we're going to draw, and if you remember, I told that the line is always going to be the straight line. So that means we cannot twist the line. The line cannot be like I don't have, let me just use my, yeah, I think line cannot be like this, right? So we cannot draw this line, right? Because that is not a straight line, and that's why, and that's the limitation of the linear regression. And that's why we need an other algorithm, or we need an other solution that can help us to, to classify such problem where we need to categorize the class of the object in one of them. And obviously, once we come into that side, we are not going to be 100% classified. Like I mentioned, in machine learning, it's always going to be close to 100%. It's not going to be certain. Let me put this way: the class is going to be certain, but there is going to be a probability that the object can be part of class 0 or class 1. So in this case, we have a certain probability that the person is going to be survive, which is 1, or we have a certain probability that the person is not going to be survive. Now, we are using a term probability. So now here you can see beside the math, we are now bringing the statistics slowly into the picture. Now, the good news, you don't need to know the full, statistic to learn the machine learning and the data science, because you just need to know the relevant concept which can help you to just understand these terms and how they work, so you can use it. And like I mentioned even previously, normally we prepare our data and then we have all these models built as a black box. We just need to feed the data into our black box, and then we'll see what the information we are getting. And obviously, it still work for you. It still provide you some really good result. We're gonna see in the accuracy, and we're gonna see the other matrices to evaluate the performance of our model. But obviously, once we use to build this model, and once we see that, okay, yeah, models are working, let me just move it. That's one. Then obviously we want to improve the efficiency of the model, and that efficiency can only be improved if we know the internal working of the model, because that will really help, or empower us to improve the efficiency and the accuracy of the model that we are using to predict things. Now, coming back towards the logistic regression, like I mentioned, we have a new concept called probability. Let me write it down in here. Probability, which is chances for occurrence of a particular event. So, for example, if we are expecting an event to be happen, so that event can either be happen or not. So for example, if I see the cloud on the sky and I say, okay, there are chances that today is going to be rain. Right now, this statement, I'm trying to actually predict the probability. So if someone asks how much sure you are that the rain is going to happen, by looking at the density of the cloud and the volume of the cloud. For example, I say 80% chances. Right now, that 80% chances, we call it probability, right? So if I say, for example, let me just put it 80% chances of rain today, right? So I'm just giving a probability, and let me just call chances of rain is equal to X, right? I'm just giving it a variable, and the technical, being a technical, we love to assign variable to our values. So now I'm going to use X. So let's say P is the probability, and I'm saying that P of X, by looking at the observation, in term of my opinion, but being myself looking at the cloud and taking some observation, I'm saying that, okay, the chances are, or the probability is 80, which is equal to 0.8, right? Now, obviously, if that's the claim, that what would be the opposite of that claim or contrary to that claim? Is, let me show it with x. It's going to be, so once I say 0.8, that means the maximum chances is for anything to be happen is 100%, right? It cannot be more than 100%. So because I'm showing it between 0 to 1, you can see we have 0.8. So that means I'm going to show 100% with 1. So what's the other side? Like, what's the chances of rain is not happening? Or what is the chances of my claim is going to be false? So I'm going to subtract my claim, which is P of X. I'm saying that the chances of rains are 80%. I'm going to subtract it from 1, which is actually 100%. And as usual, I'm lazy to type. I'm going to say 1 minus 0.8, which is equivalent to 0.2, right? So that's how the probability work. And why we need to discuss this, because that is very, very relevant for the logistic regression. Once we run the logistic regression, it returns us the probabilities for each class where the algorithm is classifying. And obviously, we take the class to as a recommendation or prediction where the probability is high. So for example, once I run the logistic regression on this data set, and it is returning, oh, there is 0.2 chances the person is going to be survived, and there is 0.8 chances person is sorry, there is 0.2% chance person is not survived, and there is 0.8% chance that person is going to survive, or 20% chance person is going not going to survive, and 80% chances that person is going to be survived. So I'm going to take obviously the classification for that particular record as a survive, right? Because the probability is higher on that side, right? But now the problem is we can't apply the probability on the single line, right? Because we already have seen the equation in the linear regression model, which is obviously won't accept any non-linear relationship, right? But in here, I need some way that can cover most of these points, which are either on 0 or on 1, right? So fortunately, we have a function called logit, and I'm just gonna show you in the documentation as well. A very simple function. You can see this formula. By the way, we're gonna prove this formula in the mathematical derivation of logistic regression. Very simple and easy to understand. Now, that formula, what it does, it actually take the same parameters like we can see in here, but it convert it into the probability paradigm. So it will actually give us the probability derivation of the curve once we use it. And you can see it is using the same equation, or at least same parameter. Like if you remember in the last video, we have discussed this mx plus c. That was our linear regression equation. Not working. Or somehow, okay, yeah. Linear regression, right? And that was only for one variable. And if you remember, I showed you for multiple variables, we have b naught plus b1 to x1 plus b2 x2 plus all the way, right, plus epsilon. And epsilon is more like the error, which is obviously we are not going to predict 100% all the time. Now, if we want to, like we have seen that we are still using the same plane, we are still using the only problem that we cannot drive the line, right? So if we have this data set and we want to build a function that can, drive a non-linear relationship for this kind of data set, we use the logic function. And logic function, it just what it does, it actually can use the probability distribution, and it convert the outcome into probabilistic way. So you can see that we have now a curve, because like I mentioned, it's not going to be a linear function anymore. It's going to be obviously the based on the probabilistic derivation, or based on the probability. And you can see we have derived it. I think now I know why this line was moved up. Let me bring it back in here. I think that's better. And to be in here. Yeah. Now that diagram makes sense. So you can see that it's going to be cover most of the point from 0 and 1, and whatever result we are going to get, that is going to be based on the probability. So that's how we use the logistic regression to predict the classes, where we have a certain number of classes, and we want to show that, okay, object is belonging to one of these classes. Now, one of the biggest challenge that how we are classifying the object based on the probability. Like I mentioned, that okay, if I apply the logistic regression, that's one of the challenge, and we're gonna see later on how we can resolve this challenge. That what's the threshold which determine the classification of the object between classes. So for example, in this example, I know that okay, if 0.2% chance that the person is not going to be survive, and we have 0.8% 0.8% or 80% chance that person is going to be survive, so we're going to classify, yeah, person is going to be survive. But what about if we have the 49.45% chance that the person is going to be survived, and 51% chance the person is not going to be survived, right? So you can see now these areas, and considering we have high volume of records, so these areas are going to be difficult to predict, where the probability of both sides are very close to each other, right? So that's one of the challenge. We have multiple solutions. Don't worry about it. We're gonna see, because normally we won't use only one algorithm in the real life. We always try to apply multiple algorithms, and then we collect the outcome, and then we predict, okay, what will be the best, or the right classification of the object are. And always remember, in the real life, you always apply multiple algorithms, and then you either get the most common one. There are many matrices, and it really depends which one suits according to your problem, right? There's not a silver bullet that you can plug in and it's going to actually start working automatically. There are a lot of changes that you do based on the requirements given by you, or particularly which are linked to your business requirement, right? What kind of problem set you are targeting, or what kind of solution you are targeting through this machine learning algorithm, right? So hopefully it makes sense that why we use the logistic regression, and why we cannot use the linear regression for classification problem. What we're gonna do in the next video, we are going to look at the data set which we are going to use to build our logistic regression using PySpark within the Databricks environment. So thanks for watching. Please like the video or put any comments if you have any question. Otherwise, I'm gonna see you in the next video. Thanks for watching.